Hello and welcome back to Calculus 2, section 6.4 on shell method. This is going to compute volume of objects that you can obtain by rotation, just like the previous lecture, but it's going to do it differently, and it's going to give us more flexibility in certain cases and definitely not work in other cases. So these two methods will not be competing against one another. They are complementing one another. You might have a situation where one method is possible, the other method is not possible at all. You might have a situation where both methods are equally viable to use, then you use your favorite one. Or you might have a situation where one is easier than the other. For instance, shell method gives you one integral, disk method gives you two. So you pick shell because, remember the low energy state we talked about? So what is this shell method? Well, for disk method, we used to cut perpendicular to the axis of rotation, and every cut we made was creating a little infinitely thick disks or washers. So when you have a rotational object, right, the one object that you created by rotating a function around, our disk method was cutting perpendicular to the axis of rotation, creating disks. And when you put those disks next to each other, right, some are larger disks, some are shorter disks, right, less radius, when you stack them together, you come up with a shape. If you ever bought those bundles of CDs and DVDs earlier in the day, right, if you had a CD or DVD burner in your computer, you would buy those stacks. And you know that if you put those disks on stacks, you get a long cylinder, right? Or short, if you buy 25 pack or 50 pack, you buy 100 pack, right? It comes up to be tall. Now, your disk method was cutting perpendicular to the axis of rotation. So axis of rotation goes through the object, and now you have perpendicular cuts. The shell method is going to cut parallel with the axis of rotation. So it's going to take slices this way rather than that way. So now, if you imagine me cutting this, it's going to create shells, right? Because you are going to have a shell over here, and then another. So there will be like little rectangles that are round, and then a bigger rectangle, and a bigger rectangle, and they're infinitely thin. And then when you take those shells, which might look like this, one shell, you put another shell on top of it, and another shell on top of it, and you stack all of these shells, you come up with this shape. So we have now a completely different way of cutting. We are going to cut parallel to the x-axis, which will allow us to use different situation like dx and dy. So I will give you a better formula than the one presented in the book, and then we will also reduce it to the one that is given in the book. So if you, I did mention Larson book at one point in life in this class. So this is the way that book explains the concept. So if you have the xy coordinate system, and you have some kind of a function over here, f of x, here's the coolest thing in a galaxy. If you rotate object around y-axis, you will be using delta x, because delta x is parallel to your axis of rotation. Now, this is the time for me to quickly jump in a previous lecture and remind you, when we go up to one of our examples, that every time when we looked at these, here's my representative rectangle dx. Observe that dx is perpendicular to axis of rotation. So disk method is perpendicular, shell method, as you can see, is parallel. Now the formula. The formula, in my opinion, which is never humble, by the way, is very cool. We have 2 pi integral, and they're using p of x, h of x, dx for a y rotation. So again, this is in Larson book. Oh, I forgot my a and b on integral, right, the limits of integration. P of x, h of x, huh? What? It's a really cool thing. I love it. P of x is the position, and h of x is the height. So, in my case, right here, the position P of x is equal to x for this simple picture. And my height, h of x, is simply equal to f of x, because the bottom is 0. So it's actually f of x, I'll put it in, f of x minus 0, which is just equal to f of x. So you immediately see that this method, the way that it's designed, immediately leaves you with the opportunity to quickly come up with the integral that has the 2 functions. For instance, if I have a function that goes like this and a function that goes like that, and we are rotating around y-axis, I have function f on top, function g on the bottom, and I draw representative rectangle over here to set up my volume. We put 2 pi a to b, which is a, and where they intersect over there is b. And now we have, let's write the formula p of x, h of x, dx, so that I can do 2 pi a to b. Now p of x is just x, and the other one is f minus g dx. Top minus bottom. This is really cool. Really cool. One thing I never talked about is dimensionality of these formulas, to make sure that we are actually getting the concept we want. If you think about this, x provides a dimension, function provides so you have the length times the height times dx, so that's 3D, so it's volume. Good to go. It is a three-dimensional equation. Nice. So this is more general case over here, right? When you have to find the method between 2 lines. So let's do a vanilla example to practice this. Let's practice this on a simple triangle. Really? This triangle has the height of 4 and a width of 5 And we learned that we are supposed to rotate this on y-axis if we want dx. So now I need to figure out this function, which is y equals 4/5 x, and it's negative because the function is going downward to the right, and then plus 4 for our y-intercept. So this function is actually y equals 4 minus 4/5 x. I will draw representative rectangle dx, and for the volume 2 pi integral 0 to 5 x times, and now I have the function minus 0, so that will be 4 minus 4/5 x dx. As I said, very simple calculation. Don't forget it's 2 pi. It's not there for decoration, right? We have a 4x minus 4/5 of x squared dx, and we can finally solve this stuff. So 0 to 5. Integral of 4x would be what? That's 2 will be 2x squared minus 4x cubed over 15. Computed from 0 to 5. That's x cubed over 3, so 4x cubed. Yep, alright, all good. Why did I put integral sign here? No one would ever know. We're not supposed to have integral sign there, we integrated, okay? So now, 2 pi, open parenthesis, plug in 5, so that's going to be 2 times 25, that's 50, minus plug in 5, that's 125 times 4, that's 500, over 15, that's going to be 100 over 3, or something like that. This one? It's x cubed over 3, right? And then you have 4/5 in front, so 4x cubed over 15. No, you have x that you have to distribute. Yep. As I said, that algebra is terrorizing. So this is 100 pi over 3. Or something like that. Is it? Whatever, who cares? It's numbers. It is? Hey. I'm sorry? Good.
Yeah, it's entirely.
Shelley says good, it's good. So that was your shell method. Please note rotation on y, and it was dx integral. Let's work out example from homework, from your textbook for this particular. So they want us to rotate on y-axis. Oh wait, this is a different book. Go to. Well, I can have only one instance. Wow. Okay. And volume by shells. Shell method. Here's a beautiful example. 10. The function is y equals 1 over 1 plus x squared. You all know what that looks like, right? Perfect. Y equals 0, x equals 0, and x equals to 2 rotated on y axis. So this is the info given. Now, the function that it's given to you is a bell-shaped distribution function. Looks like that. Now we have your y equals 0, x equals 0, and x equals to 2. So it has to be cut off on this side because it leaks. It goes to infinity. Still bounded, but... So now we have 0 to 2, and we have our, maybe you should put red, we have our y rotation. If you pay attention here, you will see that the object is bounded from all four sides. The area. You have this line here, which is x equal to 0. You have this line here, which is y equals to 0. You have this line here, which is your x equals to 2. And then you have this piece, which is the 1 over 1 plus x. So the object is perfectly confined, right? The area is perfectly confined within these values. Come on. Thank you. Thank you. Now, maybe I should, again, color the area of interest right here. So now that we know what the area is, we are supposed to write the formula for this. So I have volume is 2 pi integral 0 to 2. That's clear because they're given to us. Both of the numbers are given to us. So 0 to 2. Remember that the first one is x. So when you draw your representative dx, the position P is in between axis of rotation and the representative rectangle, which is measured by x. Times 1 over 1 plus x squared dx. Oh, this x makes the problem a little bit tougher than we really needed. If this x was not here, what's my integration? Very good. Inverse tangent. You need to be recognizing this inverse tangent. Are you planning on differential equations? Are you planning on chapter 7 in Calc 2? Inverse tangent, derivative and integral. Yeah. Now, this x really messes it up, right? So we have to do now what, because this x is around. U sub, very good. U equals 1 plus x squared. Du equals 2x dx. I already have 2x. You see that? I'm just going to steal that 2 from the pi. We can do that. So v is equal to pi integral of du over u. And my limits have to change now because I am hopping the domain from x's to u's. So plug in 0 in original problem. 1 plus 0 squared is 1. Plug in 2 in original problem. 1 plus 4 is 5. Now, the coolest thing about switching the limits is you don't have to go back to x. Good effort. You can just compute in u, use u limits to calculate the number, and you're done. What's the integral of du over u? Log of the absolute value. Thank you. So ln u in absolute values from 1 to 5. This is now equal to pi. We have now ln 5 minus ln 1. We don't need absolute value anymore because we are plugging in positive 5. We're plugging in positive 1. So no need for absolute value anymore. This is just going, what's ln1? 0, great. So we are having our answer. Pi ln 5. And if you're interested in decimals, you go and punch this in the calculator, it spits out some decimals for you, and you go make your thousands of dollars as is needed. So this was problem 10 in a textbook. Could have been on your homework too. I don't know. Just work around it. All right. It's time to do something a bit spicier. Problem 12 is going to intersect two parabolas. Parabola on top is y equals negative x squared plus 4x plus 2. And the one on the bottom is y equals x squared minus 6x plus 2. Rotation is on y-axis. Go. You draw your representative rectangle. You know you must use dx because you have y rotation and a shell method. They all work together. Like a triplet. Rotation on y, dx, and all functions have to do it. Talk to people next to you if you can stand there. It's okay.
Yeah, I ask them all every day, like, why do you charge your phone and deal with it? Why do you? That's why he's gone. When they 0 and 5, right? Yeah. I've jumped the phone. Here, he has I didn't know. I forgot to take here's the next time. Is that X still there?
Now, how do you practice this?
It's on one side. Okay, my bad. Yeah, all right, thank you. Yeah.
How's the headache?
Yeah, I guess it's what comes in. You know what? Maybe it's too
No, it's negative. Once we have done the code, I will explain it.
I haven't seen that many. I just got 625, so.
You got to memorize. Can you figure out all one over It's in section 4.9.
Didn't write it
We
right.
have to remember.
Just like you memorized that the this is one of the things.
You're getting rid of the
Take a look at 4.9, that's the table. Each one.
All right, let's take a look at this problem together. First order of business is to find A and B, which would be our limits of integration. For that, I'm going to equal two functions. So, negative x squared plus 4x plus 2 is equal to x squared minus 6x plus 2. Bring everything to the same side, so 2x squared minus 10x equal to 0. And then you can cancel by 2. So we have, or you can just factor out 2x to get x minus 5 equal to 0. 2x equal to 0 to give you x equals 0 as a limit, and x minus 5 equal to 0 to give you x is 5. Great. Volume is going to be 2 pi integral 0 to 5, and now we have top minus bottom. Oh, first we have x, right, for position p, and then we have top minus bottom, so it's negative x squared plus 4x plus 2 minus x squared plus 6x minus 2 when you apply minus everywhere, dx. We have 2 pi integral 0 to 5x, and in parentheses over here we have negative 2x squared plus 10x. These guys cancel, dx. One more row to simplify, 2 pi 0 to 5, and now we have negative 2x cubed plus 10x squared, no coughing, dx. Now, 2 pi, this is x over 4, so it will be x to the 4, negative x to the 4 over 2, because it cancels with the 2 in front, plus 10x cubed over 3, calculated from 0 to 5. Now, this being polynomials, we don't have to worry about 0. You have to worry about 0 if you have cosine or exponential, e. You have to worry about 0. But now we don't, because these are polynomials. All I need to do is 2 pi. I have negative 5 to the 4th is 625, so I have negative 625 over 2, plus x cube 125 and a 0 at the end, over 3. Now here's the little hack that I'm going to do. I'm going to multiply with this 2. Rather than look for common denominator, I'm going to multiply the 2, which will cancel the 2 inside. So I have negative 625 plus the 2 will not cancel 3, so you just double the number on top. That's 2,500 over 3. And now when you look for common denominator, it's much easier, because you just have to fix one number. So pi, this is over 3, times 3, that's 1,800. And then times 3, it's 60, and 15, so 1,875, right? Negative, plus 2,500. Now we have to subtract, and it's 625 pi over 3, right?
Yeah.
Oh, thank you. Scroll up a little bit, sure. I did. He said a little bit. Integral of s cubed is x to the fourth, right? N plus 1. There's x in front that you distribute inside.
Oh, the X on the outside, you added that.
Let me get loud. Yeah, it's not there for decoration, right? All right, let's rotate shell around x-axis because we can. What happens with the shell and when we rotate around x? We use dy. Very good. Why is this box here? Go on. Problem 15 looks cool. Y equals 4 minus x. Y equals 2. X equals 0. Rotation on x. Go.
There's a Calculus2 over here, implicit differentiation. You need a max. Look at that. That's a girl determination. Definitely. Definitely. Look at the last page. He told me that I'm not in it. Now we look for the name.
I hope I don't ever use a notebook in class. Not, mine doesn't have anything personal in it though, just math stuff.
No, he's gonna end up on the end of the class.
No, you don't have to. But I do think they're going to. Maybe you should.
What is our shape? A triangle. Good.
Professor, is there a way to tell which function is f of x and which one is b of x?
Well, you have to look which one is on top and which one is on the bottom, right?
But in the terms of
Well, they're
y,
both
it's
at the
right
same
and left,
time.
right?
You have y equals 4 minus x and y equals 2. One is going to be on top, one is going to be on the bottom when you draw. Is there a way to know it looking at the thing? Most likely no. I mean, you can calculate the heights, what we talked about last time. Calculate height at 1. That would reveal it. But once you draw the graph, it will immediately be obvious. So I'll do this in about 57 seconds. We have a y-intercept at 4. And then we have a negative x, which is the slope of negative 1. So the line would go down. We have x equals 0, which is y-axis. We have y equals to 2. So it seems that our area is this triangle over here. Because that triangle is bounded by 2 and y equals 4 minus x. We are going to rotate around x-axis, and x rotation plus shell is equal to dy. You will use this as a formula. By the way, if you are not allowed to have any cheat sheets or anything like that for the test, obviously. But if you tattoo this on your body, there's nothing I can do about that. There is also rotation on x plus disk equals dx. So that's next topic. Anyway, so now I know I need dy I'm going to set up this integral. So volume is equal to 2 pi integral y limits are 2 to 4. Now I have my position, p of y, which is just y. And for my dy, here, green, I have to do right minus left, but left is 0. So technically all I have to do is this. But hold, that's in terms of x. I need in terms of y. So we have to massage this into x equals 4 minus y. There we go. dy, that's 2 pi integral 4y minus y squared dy 2 to 4, and we have 2 pi to integrate this y squared over 2, so 2y squared, minus y cubed over 3 from 2 to 4. And what's the number at the end? Anyone? I see how it is. Yeah, I ask questions, just crickets on the other side.
I got 32 pi over 3.
Perfect. I don't know what the answer is. I'll just take that one. Good enough. All right? Thank you. Good. We have to draw the graph from the information given. We have to look at the graph, right minus left, top minus bottom, depending what we have, and go from there. Now is the time to discuss Larson, those 4 diagrams you have seen. It's time to see these formulas. They're not formulas, they're like recipes for success. X rotation plus disk method or washer equals dx. X rotation plus shell equals dy. Y rotation plus disk equals dy, and y rotation plus shell equals dx. Please note that they are completely switched. When you have x rotation for disk, you have dx. When you have x rotation for shell, you have dy. So those 4 diagrams that you took pictures of earlier are crucial to learn which way we set these things up. So if I have my disk, and in blue over here, my shell. So 6.3 in red and 6.4 in blue. So for disk method, we can rotate on x-axis, which means we are using dx, or we can rotate on y-axis, which means we're using dy. They are perpendicular. The dx and dy are always perpendicular to the axis of rotation. Now, on the blue side, if we have x rotation, we have dy, and if we have y rotation, we have dx. They are completely opposite from the red side, from the disk side, which is why we need them. We need something that is different, not the same as the one we had before. Now, to practice something like this, I already hinted to Mike in front. All you need is an apple at home. Apple is round, right? So you can obtain an apple by rotating the outline of apple around an axis, and you can take a knife and cut through the apple.
Is that like a bomb from the Legend?
I was about to, yeah, that's exactly why I'm going with this over here. Looks like a bomb.
Yeah, I was gonna say, that looks like that.
Who is going to draw an apple now? No one? Great.
Yeah, we'll do the bomb. It's fine.
Fixed. Okay. There you go. So draw an apple. So hopefully you will all agree that there is a rotational axis of symmetry through the center of the apple, right? An apple should be okay, right? Symmetric. If you're allergic to apple, do the lemon. I don't care, right? Now, if you bring a knife this way to cut through, you will have discs. If you cut the apple that way, you will end up with round discs. As a kid, I was observing my mom making some dessert where you cook the apples and do things. You stuff apples with like some nice mixture with walnuts and things. If you're allergic to it, more for me. Great. So there is this tool that it's like a tube that you push through the apple and just bore the inside with those seeds and things, right? And then you just have a holy apple, right? You just put the hole in the apple throughout the whole thing. Now, if you are to take that apple with a hole through the middle and cut this way, you're going to get discs, right? Like CDs. Don't try to play them. But you can also take a knife to the same apple and cut this way, in which case you get shells. I need you to go home and take the apple. You can get apples for 49 cents a pound. I just need you to get one apple. Maybe you can be creative enough, they might sell you half an apple. I don't know, right? Your negotiating skills, right? Just, yeah, I would love to see that debate. I would like to buy half of this apple.
I'll buy some apples. I tried to buy 8 from a watermelon, and
Yeah. That's why I just sent those slices. And I think they're like $1,300 for the watermelon, like the quarters, yeah, or eighths.
I've seen them again.
So please, when you get home, if there's an apple available or a lemon, if you're really precise, you can do it with a grape or a blueberry. That would be a good one. I need you to see the difference between a disc and a shell on an object that you can take and cut, right? So apple is the best bet because you clearly see where the axis for rotation is, right? And then cutting the apple this way would give you discs. Cutting apple that way would give you shells. You will learn that the axis of rotation and these kind of cuts, they are parallel for shell. You will learn that axis of rotation for the apple and cuts like this that makes discs, the cuts are perpendicular. So when you see a problem which says, figure out which method you want to use, you are able to use either method. It doesn't matter, right? If they're both possible. Or you are able to recognize that one method would yield two integrals, the other method would yield one integral, and then you do that one, right? Because it's easier and cheaper. So the last problem for this is going to be problem 14 from the textbook. I'm not going to solve this thing. You can solve it. I'm just going to talk about the setup. Oh, it's a bad time to leave, but that's okay. We're going to have a break in like 5 minutes. Yeah, just to hear this discussion for the... So the problem looks like this. Your region is clearly stated. And we have x rotation. And this is square root of x. This is 2 minus x. And we have 0 on the bottom. They even go as far to tell us these numbers on the x-axis because they really don't want us doing any work. They just give us everything. What shall we do? Well, when you rotate around x-axis, you are left with x rotation choices. X rotation plus disk is going to give us dx. X rotation plus shell is going to give us dy. These are your two choices. You look around, everything is easy to flip, so we can use either one. That's fine. Let's see which way we get to be lazy, which way we get to do more work. If I'm using dx, what can you tell me immediately? Two integrals, thank you. As this dx goes from 0 to 2, it will switch the top function from root x to 2 minus x. Do we all see that? Because if I draw delta dx on this side, here we see that the bottom still rides y equals 0. The top switched the function. So dx is two integrals. How about if I do dy, which is blue? How many integrals do I have for dy? One integral, right? There's only one integral for dy. Because the bottom, you draw here, the top is all the way up to the point, and the right side always rides the linear line, the other side always rides the square root, so a single integral on dy. This problem can be solved both ways, and this is my challenge to you for next class. You will practice the cuts on apple, if you're interested in these things. Otherwise, don't worry about it, just forget it. The reason why I want you to cut the apple is because I want you to see those shells. I know that you all can imagine those disks. Disks are fine. Shells are issues. There are some pretty cool pictures that you can see in a book and so on. Nothing beats cutting very thin slices, right? You're not going to waste that apple. You're going to eat that after that, right? Especially if you're allergic. Please. So that's that. Solve this problem both ways. Your dx is going to have two integrals. You add them. Your dy is going to have single. Your final answers for both better be the same number because it's the same object. One thing that you are not allowed to do is to change your rotation. You are not allowed to take your arrow from rotating around x and put it on y, because that way you're just going to have one integral on disk method. Because when you switch the rotation, you switch the volume, change the shape of the object, and you change its volume immediately. And that is something that you really can't play with. Unless the object is perfectly symmetric, there are a lot of requirements for this type of symmetry to work in order for the rotation, to switch the rotation and get the same object. Yes?
Are we going to combine rotations at all?
No.
No.
Because they're completely opposites of each other. They complement each other, right? So you will not be combining these ever. You will be deciding which one to use, which one is easier, or which one is possible. Because remember that parabola bends on its own, not on itself, so that would eliminate a possibility for you. So as I said, in some cases, one of the methods, shell or disk, is not possible at all. In another type of a case, one is better than the other, like in this case. And in the third case, it really doesn't matter which one you use. So for a triangle problem, if you had something like this, rotating on x, it doesn't matter which one you use. It's going to be one integral either way. But that's a joke of a problem, right? So we don't have to worry about it. So in some cases, both are equally good. In some cases, one is better than the other. And in some cases, one is not possible at all. They don't compete. They complement each other. And that's the end of the story. Mike?
Now, do you remember how we did the run some of this method and you can actually see how it was sliced? Is there something similar?
That's what I want you to do with the apple.
No, I know, but the image of that.
Sure. For the
shell method.
yes. They only have terribles. I'm not too happy with the images, but it is what it is. You see that? It's like these tubes, right? There are one inside another, inside another, inside another, all stacked together, right? Now, if you are only looking at the delta y slice, which is the delta x slice, sorry, right here, if you are to cut the apple, you're just going to get a sliver, and it's going to look like a shell. So that's why it's called the shell method. The images for this are not too good, which is the reason why I want you to go and cut that apple and actually see it. That's what it is. Better? Yeah, I know. That's why these books are like $200. As soon as you look at it, it makes sense. The problem is to get people to look at it. Plus, I mean, technically, when you think about what, a book is like $250? $260? $330. Okay. $330. You have about 1,200 pages. Divide that by 330. Amount per page. right? Divide 330 by, you get the price per page. Now, if you only open the book once, then clearly you pay 330 for a page that you looked at. If you look at every page, right? I even read this stuff over here. You see this? As a student, like these things. They're awesome. If you can't fall asleep, you read this type of stuff. If you ever had a user agreement for anything or something like that, read it. You instantly. It's amazing. Nothing else can knock you out as reading the user agreement for, I don't know, a hair dryer. It's amazing. People say insomnia is, no, just no one told them. Read the user agreement. Yes?
Give an example of a function that you can't do this with.
Yes, simple x squared.
Okay.
So the question is, give an example of a function where we can use one method but absolutely cannot use the other one. So it's less convenient, two integrals or anything. The other one cannot be used, period. All I need to do, and I'm going to draw and then erase because I want to leave this next class. We need to discuss this. I'm really hoping that you are going to spend time and figure this out, guys. Here's the example. Whee! And then it's going to rotate on x-axis. I could have picked either one. Doesn't matter. So if I have this...
Are you worried like
Oh, why don't you say so? There we go. So this is your example. This is some kind of negative x squared function. Well, actually, we can know exactly. Give me the coordinates of this point. 3, 7, right? 3, 7. So if this is 3, 7, I can write the formula for this as y equals negative x minus 3 squared plus 7. There you go. And then now you just multiply, FOIL everything, and put it together. So if you know the coordinates of the vertex, your agent k, you can stuff this in your pre-Calculus 1 formula from chapter 2. And you can come up with the exact equation of what it is. Now, let's talk setting this thing up with your shells and disks and things like that. It's x rotation, and now I'm going to look at my x rotation here. And what do I see? X rotation plus disk equals delta x. Can I do dx? Yeah, bueno. So disk works, and it's one integral. That's also cool, right? Now, how about shell? Shell on x rotation requires dy. Look at your dy. It folds on its own, on the same function, right? Left and right are both writing the same function. So you're going to have this minus itself when you set it up, right? That's bad. So shell cannot be done at all, cannot be set up at all. So here is the example of a function where one is possible and one is not possible at all. As you do your homework, you are going to run into these, hopefully. Otherwise, your homework is garbage. But lucky you have Ethan to ask questions, so now you all know. Excellent question. Are we all good? Well, the next one is length of curves after taking a short break. Go, run.